In the previous video, we made this visualization of our data. And most important thing to notice from this visualization is that these red points, which all correspond to -110 odds, that they all seem to lie on a line, or there seems to be a line which well approximates those points, is a more accurate way to say it. And in this video, we're going to use scikit-learn to find what's the equation of that line. And it took a long time for me to get to the point where this syntax seemed intuitive, but scikit-learn has good documentation. And so when I get confused about how do you do a linear regression with scikit-learn, I just go to the documentation and scroll down to the examples. So the key thing here is this .fit method. So I need the data, and let's just copy it here, because I'll want to change the parameters in a little bit. And then let's say reg equals linear regression, okay, with these parentheses that creates a new instance of it. And then fit, and the x coordinates are going to be for this true prob. So in that case, it was from probs. And in this case, ROIs was the y coordinates. And it's going to give me an error. And why does it give me an error? Because by default, linear regression in scikit-learn is set up to handle multiple input variables. So not just one input variable like input true prob, output ROI. It also could take something like input true prob, input odds, output ROI. And so when I just give it a one-dimensional array like this probs, okay, let me show you what probs looks like. Then it gets confused because it doesn't know like how many input variables are there. And so we can sort of force it into a two-dimensional thing. And this is actually shown in the error. It says do this reshape -1, 1. And so the 1 is saying there should just be one column. And the -1 is a shortcut that says use however many rows you need, or use however many in this position that you need. So it looks very similar, but now it's set up as like a column array or a column vector instead of as a one-dimensional array. So let's see, let me cut that and put it back up here. Oh, and then I should say probs equals. Okay, so now I didn't get an error. And so the problem that I had before that I just fixed was when you say this, that like tries to print it out, but since it's not on the last line, it doesn't get printed out. And so the result is just sort of forgotten. Here, I'll do it like that. And I see that I lost the definition of probs at some point, so let's bring that back. Okay, and hopefully this will work. Okay, good. And so what does that get me? So what you should think is that ROI equals M times true prob plus B, okay, approximately. Okay, when we have random processes like this, it'll never be exact. And so what scikit-learn does is it finds M and B. So M is this reg.coef attribute, and B is going to be reg.intercept. And let me show you what M looks like. So it's not just a number, but it's like this little length 1 array. And that's for the exact same reason that we needed to do this reshape. It's because by default, linear regression coefficient could be one number for each of the input variables. And so here it's one number for each of the input variables put into an array, but we don't really need that in this case. So we can just say, take out the 0 thing in this array. Okay, and there it is. And if we want to try to solve, so when is ROI equal to 0? Okay, and that will correspond to the break-even probability. So we want to solve 0 equals m times true prob plus b. So we have true prob equals negative b over m. And so let me put all of this stuff together. So that I can evaluate the whole thing once without having to evaluate multiple rows. And then let's just print out this negative b over m. Okay, so this is my simulation's estimate for the break-even probability. So it's pretty good, not exactly my 52.4. How can I get it better? Well, of course I can get it better by making these numbers bigger. And so I practiced beforehand to see like what's the biggest numbers I can use without it taking too long. So let's use 1,000,000 repetitions and let's use 1,000 simulations. Okay, and this should take about 10 seconds. So that's looking great. 0.523812. And what was the true number? The true number was 11 over 21, which is 52.3809. And so I can't expect it to get much more accurate than that. If I want to see what's the difference between these, okay, I can subtract one from the other. And the only problem is it shows it to me in exponential notation. And so I just learned this morning. Let me show you how to use f strings in Python to convert this into just regular decimal notation. So I can say this f, and then inside the apostrophes that says make what's called an f string. And I think this showed up in Python 3.6. And here I'm in Python 3.7. It goes up to 3.9 or maybe even 3.10 now. And then I can say, replace this value diff or format it by using, let's say, 0.10f. And so what this stands for, I had to look it up. This stands for give me 10 digits past the decimal point. Okay, and so the difference between these is 0.000033. And I think that's a pretty impressive amount of precision for using these free tools just on all the computation being done on the internet. None of it was done on my computer. So yeah, thanks very much for watching, and I hope some of this made sense, and I hope it gave you some appreciation for some of these like really powerful tools that you can use on DeepNote, or if you want to use it somewhere else on Google Colab or on a Jupyter Notebook on your own computer. Yeah, thank you for watching.